There is a black hole at the center of your galaxy, not somewhere across the universe, not in a galaxy you'll never visit. At the center of the Milky Way, 26,000 light years from where you're sitting right now. It has the mass of 4 million suns. And in June 2025, scientists used AI trained on 12 million simulations to analyze Event Horizon Telescope data and confirmed something most people will never hear about. It is spinning at nearly its maximum possible speed, and its rotational axis is pointed directly at Earth. Here's what that actually means for the space you live in. The black hole isn't sitting still. It is spinning so fast, it is physically dragging the fabric of space-time around with it, like a drill boring through water, pulling everything in its path into the rotation. Every star, every gas cloud, every particle of matter within thousands of light years of the galactic center is being pulled, not just by gravity, but by the rotation of space itself. There is no still point near it. There is no neutral ground. You've been taught that black holes are distant, rare, exotic, something that happens to other stars and other galaxies. That framing is wrong in almost every direction. Astronomers now believe supermassive black holes exist at the center of virtually every large galaxy, including ours. And in May 2026, the LIGO V Ergo Kagra Gravitational Wave Collaboration released its 5th catalog of detected black hole mergers. 161 newly observed events from April 2024 to January 2025 alone. 161 black hole collisions in just 9 months, detectable from billions of light years away. Black holes are not rare. They are the dominant structural feature of the universe you live in, and the nearest stellar black hole to Earth, Gaia BH3, is just 2,000 light years away. Discovered in 2024, it was there the whole time. We just couldn't see it. Here's the detail that most people never reach. Most people think of black holes as stationary, something that sits in space and pulls things in. That is not what Sagittarius A is doing. The June 2025 study published in Astronomy and Astrophysics, Janssen and colleagues, used a neural network trained on 12 million simulations to analyze Event Horizon Telescope data collected across 5 nights in 2017. The conclusion? Sphere A is spinning at near maximum speed, and its rotational axis is pointed toward Earth. That's not metaphor, that's geometry. The rotational axis of a 4 million solar mass black hole at the center of your own galaxy is oriented toward the planet you are on right now. When astronomers describe what is pointing at Earth from the galactic core, this is what is at the other end of that line, a black hole, spinning at almost the maximum speed physics allows, aimed here. Understanding why that matters requires understanding what black holes actually do to the space around them. A black hole's event horizon, the boundary of no return, is not a wall. It is not a surface. It is a geometry. Cross it, and the laws of physics as you experience them stop applying in the same direction. Space itself flows inward faster than light, which means once you cross that threshold, you are not falling towards something. You are inside a region where every possible direction you can travel in leads to the singularity. Forward, backward, sideways. All roads end at the same point. There is no movement away from it, only movement toward it at different speeds. This is what point of no return actually means. Not a warning, a geometric fact. Now consider what happens to a star that gets too close before crossing that threshold. The difference in gravitational pull between the near side and the far side of the star becomes so extreme that the star stretches. Vertically elongated, horizontally compressed, drawn into a thin stream of superheated plasma spiraling inward. Scientists call this spaghettification. Stephen Hawking described it as being stretched like spaghetti. For a human falling feet first into a stellar mass black hole, the tidal force between their feet and their head would become fatal well before crossing the event horizon. Not at the horizon, before it. In August 2025, astronomers captured a tidal disruption event in real time. A massive star violently destroyed by its black hole companion, producing a supernova designated SN 2023 Spaghettification that lit up, faded, and then flared again months later. Delayed bursts of energy as the remaining stellar debris continued spiraling inward. The star flared twice, once when the black hole destroyed it, and once again, as what remained of it fell the rest of the way in. Now consider what that looks like at a scale that makes Sagittarius A look like a rounding error. Ton 618. Located 10.8 billion light years from Earth, classified as an ultra-massive black hole. Mass: 66 billion solar masses. That is heavier than every star in the entire Milky Way galaxy combined. Our galaxy holds an estimated 64 billion solar masses worth of stars. Ton 618 outweighs all of them by 2 billion suns. Its Schwarzschild radius, its event horizon, spans 1,300 astronomical units, more than 40 times the distance from the Sun to Neptune. A beam of light traveling at 670 million miles per hour would take weeks just to cross its shadow. And here's the fact that changes everything about how you think about escape. Because Ton 618 is so massive, the tidal forces near its event horizon are actually gentler than at a smaller black hole. You could cross its event horizon without feeling anything unusual, without any physical warning, without knowing. The largest black holes in the universe don't announce themselves. You would pass the point of no return feeling nothing at all, and only realize what had happened when you looked back and saw that the entire universe had shrunk to a single point of light behind you. In 2025, a galaxy 10 billion light years away faded to 1/20th of its original brightness in just 20 years, caused by a rapid decrease in gas flowing into the supermassive black hole at its center. The research, published in the publications of the Astronomical Society of Japan, showed that a black hole's activity can change dramatically on timescales short enough to observe within a human lifetime. And in April 2026, a black hole dormant for 100 million years woke up and erupted, releasing jets of energy described as a cosmic volcano. Published in monthly notices of the Royal Astronomical Society, black holes don't stay quiet, they wait. Sagittarius A itself was 1,000,000 times more active 350 years ago. A flare so powerful, it is still being recorded today. Not by modern instruments, but by a molecular gas cloud called Sagittarius B2, located 350 light years from the black hole, which is only now absorbing radiation that left SAR A in the 1670s. What you observe when you look at SAR A today is not what SAR A is doing today. It's what it was doing 26,000 years ago, and what it was doing 350 years ago. Within that same light-delayed view, was releasing 1,000,000 times its current output. The quiet you see now is not evidence of stability. It's evidence of a cycle. And right now, you have no way of knowing where in that cycle it is. There is one more thing. When matter falls into a black hole, quantum mechanics says the information encoded in that matter cannot be destroyed. You cannot unexist something. Every particle that ever fell in carried information about what it was. But Hawking showed in 1974 that black holes appear to erase all of it. Two of the most proven frameworks in all of physics, general relativity and quantum mechanics, directly contradict each other at the event horizon of every black hole in the universe. The foundation of modern physics has a hole in it, and that hole is sitting 26,000 light years away, spinning, pointed at Earth. There is a black hole at the center of your galaxy, 4 million solar masses, spinning at near maximum speed, rotational axis pointed at Earth, 1,000,000 times more active 350 years ago. And somewhere in the universe right now, there are black holes 66 billion times the mass of the Sun, with event horizons you could cross without feeling a thing. It was always there. You just didn't know what was pointing at you. Like if you'll never look at the night sky the same way. Subscribe to Star Dread, new cosmic horror documentary every day. Tag someone who thinks space is peaceful. Drop your next fear. What should we cover next?